Hi guys, yes, good morning. Sorry for the delay. Yes, due to some in my home some
Very good
puja
morning,
and
sir.
all.
No.
Yeah, some puja going on. That's the reason
Oh,
little bit
great.
late.
No problem, sir. We can continue.
It is a special day for our ancestors.
Yes, sir.
Special day for ancestors. That puja going at 12 o'clock. We should perform that puja. That's the reason late.
Okay.
Like
Festival environment around.
who are expired for them, we should perform some something like food and all that ancestors puja, that is today.
Okay, sir.
Yes, so let us start our session. Yes. So previous class,
Sir, I was going through the four videos that you have shared with me, and I have a doubt here. As you have mentioned, there is something called a recovery factor, and by default it will be 3, and you can specify it to
today
the
we'll
extent
discuss
we
the
want
topic.
minimum.
One second.
Sure, sir.
Today we will discuss the topic. Actually, that parallel batch videos last week one batch started. That batch videos were shared you. Okay, because your batch much topics were not completed, but there is not your batch video shared. Same topic exactly, no difference. Okay, this batch 1 week back started. That videos were shared. Okay, the topic today we are discussing. Okay, right? Yeah.
Fine.
Yes. So yesterday class data storage we have discussed. Next about data processing. Yes, data storage, Hadoop data storage. Next, traditional systems data storage we have discussed. Okay. Yes, in traditional systems it's a vertical scaling, increasing volume of the server, just increasing volume of server, capacity of server is vertical scaling. Horizontal scaling, just adding number of servers, increasing number of servers. Okay, Hadoop follows horizontal scaling. Here increasing number of servers. Hadoop is increasing number of servers. So increasing volume of server is a vertical scaling, increasing number of servers is a horizontal scaling. That's the difference. Okay. Now let us see about data processing here. Data processing. Yes. Let us see about data processing. Okay. Yes, data processing, same traditional system versus Hadoop here. Traditional systems. Traditional systems, data processing, traditional systems. In traditional systems, let us take some traditional web application. Traditional web application. Web application. Suppose this is a browser. From the browser, we are submitting all the data. Maybe login form data, maybe registration form data, maybe in Facebook uploading your images, your photos, and all this. It's a browser, right? Browser. From the browser, your data goes to that Facebook application or any application. Okay, so it's a browser. So this is browser. Browser. Next application. Browser. Next is application. So your data. First of all, yes, transport application. Your data moves to application. Your data application. Application here. Application taking your data, then storing database. Let us take database. Okay, the data storing inside database. Suppose registration form details, the data storing database. Alright, okay. Yes. Suppose users information, login, for example, login request. First of all, your login details simply goes to application. Now this application has to connect database. Next, Yes, it has to validate your login credentials, right? Yes, login details. So what this database contains, for example, here 2 millions of records. This database contains 2 millions of records. There are 2 millions. 2 millions means what? How many here? 20 lakhs, right? 20 lakh of records. Okay, 20 lakh of records. 2 millions of records. Okay, 20 lakh of records. See, 20 lakh. Yes, in English and British we can say lakh, but in US there is no lakh concept. They'll use millions. Okay, tens, thousands. After they will use millions. No concept of lakh in US. Okay. Yes, 2 millions equal to 20 lakhs means 1 million equal to 10 lakhs of records. Okay, 1 million is equal to 10 lakh of records. So 2 million means 20 lakhs of records. Okay. See, these are application. When our application started, when our first initial application starting, when application started here, what are the records? All these records, the 2 millions of records will fetch into application. Will fetch into application. Instead of application, 2 millions of records storing temporarily. Okay, when application started here, when an application startup, all the 2 millions of records fetching into application. Now at this application, 2 millions of records are there. Now user, login user. Yes, user ID password. That user ID password request goes to application. Application checks instead of this. Yes, here already 2 millions of records here is available. From database to application transfer data. Not checking right. After checking if it is valid, yes, success response. Otherwise invalid request, right? Invalid login. Right, okay. Now what is happening traditional application here? Whatever data inside of the database here, all data fetching to application. Here checking here. Here login validation here, right? Suppose here this is temporary storing, right? Temporary storing. Suppose any changes made on database data here, that will update on this location automatically. For this purpose, temporary location. Suppose Java application using collections, using collection components, maintaining all the temporary data here. Okay, so request comes to here only checking. It won't go database. Already data fetched. Already data fetched, right? Already data inside of application is available here. The 2 millions of records, just checking, validating, then sending response to user, right? This is so what is happening here. Application is running. That application will be login program search, for example, search request, search program. Yes, Java program, for example, Java program search dot class. Yes, here this is search dot class, search dot class, search dot class. Here it is search dot class. Okay, so search dot class, that search dot class validating user and sending response to user, right? Now what is happening here? Data moving database to application. That means data is remote. Data from the remote server moving, right? See, data may be running on some location, at some location, application another location. Maybe data sent different tracks. This may be one track, this may be another, two different tracks, two different locations, right? The data has to transfer network. Data has to transfer network, right? Yes, it's a remote data. Data is remote. Traditional system data is remote. The data has to transfer the application. Okay, transferring 2 millions of records network, time taken, right? Time taken. So data is remote. So since it's a remote data, time taken to transfer this is. So this is what is happening in traditional system. Traditional system, right? Yes, same thing. The data processing. Yes, in traditional system, data moves to application location, then data processing. The data processing will be login validation or searching for something, filtering for something here, some details, filtering something here. All the data processing happening inside of this, right? So this is here one database server, one application, one database server, one application, right? Here data inside of one database, here application also one application. Okay. Now same thing in Hadoop. How the data processing Hadoop? Let us see Hadoop data processing. Let me take yes cluster. Not data processing. How data processing is working? Let us see data processing. Yes, master and slave architecture. Okay. Now, data job submission request. The job submission request is a search request. It's a search request. Job submission. It's a search request. It's a search request. search request. It's a search request. Here that search request goes to name node. Okay. On receiving such request, what happens here? Now, where is the data here? See, there are 20 lakhs of records, right? 20 lakh of records. Now, what happens here in Hadoop? See, in traditional system, all this data is only one server. Yes, one table, one server here. Table cannot break. We can't store in multiple servers. One table has only one server. Means whole data in this single server, right? In traditional systems, complete data, whole data, 20 lakh of records in the single database server. Because table we can't split. Table cannot be split. We can't split the table here. Okay. Storing in a multiple source, no, not possible. Yes, one table, one database server. Right? So in traditional systems, only one server. Now, let us come to Hadoop here. In Hadoop, what happens here? Same data. Let us take same data, 20 million of records, 2 million of records here, 20 lakh of records. Distributing onto multiple nodes in cluster, right? Distributing onto multiple nodes in cluster. What's the distribution strategy? Distribution logic what? 5% of total data, right? 5% of 20 lakh of records. 5% of 20 lakh of records, right? 20 lakh of records. So 5%. So 5% of 20 lakh is equal to how much here? 1 lakh of records. We have 20 nodes, right? Yesterday we have discussed the data distributing onto multiple nodes, 20 nodes, right? Now 20 lakhs of records. 20 lakhs of records on 20 nodes. So you can first node on node 1, here 1 lakh of records. 1 lakh of records. Next 1 lakh maybe here. Yes, next node 1 lakh maybe here. Some different locations. 1 lakh here. Yes, next maybe here 1 lakh here. 1 lakh. Yes, maybe like this. 1 lakh like this. Distributing onto multiple nodes, right? Distributing onto multiple nodes cluster. That means 20 lakh of records are on the 20 servers. That means to process 20 lakhs of records, Hadoop will be using 20 servers. Okay. Same data, traditional system will be using only one server. Okay. In traditional systems, only one server has to process all this data. Means time taken, right? But in case of Hadoop here, 20 servers will process the data. 20 data nodes. First node is 1 lakh here. Next node 1 lakh here. Next node 1 lakh. Okay, the data distributed and processing it. Yes, how that processing happening here? Let us see here. Now such request. Simply such request with name node, right? Name node. Now name node receiving the such dot class program. Such dot class. Now name node takes a such dot class file. After taking that, how the search happens here. Now name node takes the search dot class, that program logic, search dot class can some Java program, right? That's search logic. Name node takes the search logic. After taking search logic here, it creates 20 copies of the search logic. It will create some 20 copies of search dot class. Why 20 copies? Data is on the 20 nodes. Data is on the 20 nodes. Data is on the 20 nodes here. So it will create 20 copies. After creating 20 copies here, it will deploy onto 20 nodes. So first copy come to here, next copy, 20 copies. It will create 20 copies and deploying onto 20 data nodes. So such dot class will come to here. The such dot class file moves to here, right? Such dot class file. That copy moves to here. Such dot class, right? So here such dot class, here such dot class, next here such dot class, here such class. On 20 nodes, 20 such dot class file will be. So what is happening here? That application logic is moving to data location, right? Application logic is moving to data location. Right, okay. Application logic is moving to data location. Right, okay. Yes, in case of traditional systems, what is happening here? Data moving to application logic, right? Reverse. In traditional systems here, data moves to application location, reverse. In traditional systems, data moves to application location, In traditional system, data moves to application location. Okay. That means data is remote, right? For traditional system, data is remote. Remote data has to transfer. To transfer data, remote data via internet, time taken. That has to transfer network, right? To transfer this data network, time taken. Data transfer, here involvement of data transfer. So time taken to transfer data. But in case of Hadoop, data never transferring here. Only application logic moves to data location. This is called data locality concept here. Data locality. Okay. Hadoop following data locality. So what is data locality? Data locality means application logic move to server on which data is available. This is called data locality. That means data is local, right? Such dot class. That program is running here, right? Data is local. Here data is local, but in traditional system data is what? Remote. The data has to transfer network, right? Data has to transfer network, but in Hadoop the data transfer not required. Since it's following data locality, here, this one gives more performance. Data locality, it's following data locality here, so this one gives a more performance. Data is local. In Hadoop, data is local. Okay, that search dot class, that logic, simply search logic, that application logic moves to data location, means data becomes local. So data, this concept is called data locality. Okay, right? Yes, in traditional systems, what happens here? Data moves to application location, but in Hadoop, what happens here? Application moves to data location. Reverse. If application is moving to data location, then data becomes local. So this is following data locality concept. This is following data locality concept. Yes. Okay. Yes. Next, not only data locality here, multiple servers processing data. First server, next one, next one, like this. Multiple servers processing data. Multiple servers are processing data, right? Multiple servers. 20 servers processing it. Yes, in traditional system, only one server. Only one server, 20 lakh of records. But here, 20 servers processing it. Not only 120 servers, we have one more internal concept, slots concepts. Slots. Okay. Default 2 slots. On every node, there are 2 slots. 2 slots. That means your data dividing 2 parts. That means 1 lakh of records divided into 2 parts. First part 50,000, next part 50,000, 50-50 like this. Yeah, that we can make it 4 slots. By default 2 slots, that can be configured to 4. We can make it 4 slots. Okay, 4 slots. Okay, that we can make it 4 slots. Suppose if it is 4 slots, then what happens? The data divides into 4 parts, means 25,000, 25,000, 25,000. After dividing into 4 parts, now this search dot class, this converts into 4 copies again here. This search dot class file creates 4 copies. Now, yes, it becomes data node takes the search dot class file, it creates 4 copies. Now here the name node makes the search dot class in 20 copies, deploying onto 20 nodes. Now data node receiving search dot class here, after receiving search dot class file, it converts into 4 copies again. It converts into 4 copies. Now 4 copies running parallelly. So first copy, slot, every data node by default 2 slots available. 2 slots, nothing but 2 memory spaces. 2 memory spaces. 2 slots means 2 memory spaces, 2 child process. Okay, 2 slots means 2 child process. That means 2 programs can run at a time here. So 4 slots means 4 programs can run at a time here. Yes, it's a container, just like a container. First container, second container, third container, fourth container. In first container, 25,000 records. Next container, next 25. Next container, next 25. Next container, next 25,000. Yes, data here. Records like that. So container, each parts nothing but a container concept. It's a container. So there are 4 containers. On each data node, there are 4 containers. Each container contains, yes, 1 lakh divided by 4 means 25,000. Each container, how many here? 25,000. Okay. Now on each container, 25,000 records available. Okay, fine. Now to process that container data here, this search dot class file converts into 4 copies. First copy processing first container data means first 25,000. Second, next copy will process second container data. Next copy will process third container. Next copy will process fourth container. I think it's clear, right? Okay, so parallelly running that 4 search dot class file running parallelly here. So here 4, yes, here 4, here 4, Here 4. Totally 20 nodes. 20 nodes multiplied by 4. How many here? 80. 80. 80 are running parallelly. Okay, right? Yes, 80 instances. 80 instances running parallelly. 80 instances running parallelly here. So here 4 running. So here next year 4 running here. Next year 4 running. Here 4 running. Here 4 running. Yes, parallelly 4, 4, 4. Totally 20 multiplied by 4 here. 80. That 80 such dot class files running parallelly. Yes, each such dot class file has to process how many records? Only 25,000 records. Okay, so what's happening here? First 20 millions of records, sorry, 2 millions of records, means 20 lakh of records. 20 lakh of records distributed onto 20 nodes. Distributed on 20 nodes, right? On each node, 1 lakh. On each node, 1 lakh of records. That 1 lakh again divided into 4. That means each container or slot. Okay, slot or container. Anyone you can say. For better understanding, try to imagine container here, slots or container. Okay, see, in 1.x version, slot concept, in second version of Hadoop, container concept. Same, both are same here. In 1.x version, calling a slot here. Yes, in second version of Hadoop, calling as container. Calling as container. Okay, each container, there are 4 containers. 4 containers. Each container contains how many here? 25,000 records. So that such dot is nothing but mapper. Yes, mapped is mapper. Now the such dot class becomes 4 copies. First copy running on the first 25, next copy, next 25, next copy, next 25, next copy, next 25 like this. Parallel running here. So 80 such logics are running parallelly. That gives a more performance, right? Okay, now let us calculate time taken. See, here 80 instances running parallelly. That means time taken to process. Time taken to process 25,000 records. 25,000 records enough to process whole data, right? To process whole data. Okay, so time taken to process 25,000 records enough to process whole data. I think this point is it clear? Time taken to process 25,000 records enough to process whole data means how many? 20 lakh of records. Yes, you understand this point or not? Time taken to process 25,000 records enough to process whole data, right? This point is clear to everyone, right? Is it clear? Akansha, is it clear? Naveen? Hello?
Sir, I'm not sure if they are present. So the question here is, I mean, the doubt here is, we know that there are 20 nodes that we are storing the data because there are 20 lakhs of records. So
yeah,
the name node is sharing the search.class file to each of the nodes, that is fine. But on each of the data nodes, the search.class is again replicated into 4 copies. So may I know why it is so? I think it is because to improve the search speed. If that is the case, is it defined to 4 only, or can we increase? Is there any
one default is 2. Default is 2. Default available 2 here. That we can configure to 4. More we can't do that.
Okay.
Max default is 2. Max is 4. Not more than that. Okay.
So, sir, in both version we can have a maximum 4 slot. In both version 1 and 2.
In both versions, yes. In first version, second version, both versions are available. That facility. First version available, second version also available. Both versions that facility available. We can configure. To configure map to slots, I'll explain. Yes, in the actual topic that configurations I'll explain. Don't worry. Okay. How to configure Hadoop? Replication factor configuration, block size configuration, next slots configuration. There are many details here. Yes, we'll listen. Okay.
Sir,
yeah.
Sir, I wanted to clear one more doubt. See, here
Tell
we
me.
mentioned 5% of 20 lakhs. Does it mean कि whatever the records we are having, suppose 10 million or any. So
Yeah,
what?
one second. One
Yeah,
second.
any
Yeah,
number of.
I understand your question here. See,
Hmm.
default algorithm is 5% basically here. Default. Okay, if it is small data, it's a 5%. So we suppose yes, 100 GB data up to 100 GB data, 5% 5. Suppose 200 GB data, that yes, starting changes. That becomes 5 divided by 2 means is equal to 2%. 2% data. 2% of total data is 50 nodes. If data, yes, data size increasing, number of nodes are increasing automatically here. More size, more volume, more number of nodes. Less volume, less number of nodes. Is it clear?
Okay, means automatically number of nodes will increase.
Yeah,
Means auto
automatically.
scaling.
Yeah,
Auto
based
scaling.
yeah, auto scaling concept is available here. So based on that auto scaling, that number of nodes will be increasing automatically. Number of nodes will be increasing automatically. Okay, yeah. Is it clear? If the cloud
Yes, sir.
environment will be like that, auto scaling concept here. Automatically here, that yes, automatically number of nodes increases. Depends on the volume of data, number of nodes increases. Less volume, less number of nodes. Big volume, yes, more number of nodes. Depends on data, automatic number of nodes increasing. Okay, yeah, fine. Yeah, this is. Now this point is clear, right? Time taken to process 25,000 records enough to process whole 20 lakh of records, right? This point everyone is clear. Okay, right. Now let us take some example here. Suppose traditional system taking 20 minutes to process data. Let us take same data. Traditional system taking 20 minutes to process. Yes, the 20 lakh of records. Traditional system, traditional system taking 20 minutes to process some data. Okay, then Hadoop will take how much time here? For the same data, Hadoop, yes, will take how much time here? That we should calculate. Hadoop will take how much time? Just assume that only easy for calculation purpose. Yes, 20 minutes I'm taking care. How much time here? How much time requires? Yes, Hadoop will take how much time here? So traditional system taking 20 minutes to process some data, maybe 20 lakh of records. For the same data, Hadoop will take how much time? That is question here. Okay. Now, what is happening here? 20 minutes. Okay. So 20 lakhs of records, 20 minutes. 20 lakh of records, 20 minutes. Yes. So that traditional is because only one server is taking 20 minutes. One server taking 20 minutes. Okay. Suppose Hadoop 20 servers. Yes, in place of one server, 20 servers. That means 20 divided by 20 is 1 minute, right? So each server will take 1 minute. Each server 1 minute. Right? For one server, 1 minute. Now that 1 minute divided by 4 again, right? Means 15 seconds. 15 seconds. So for the same data here, Hadoop will take only 15 seconds. That's it. Hadoop will take only 50 seconds. Hadoop will take 50 seconds. I think clear, right? Okay. Yes, Hadoop will take only 15 seconds here. See, 20 minutes divided by 20 servers means 1 minute. That 1 minute divided by 4 means 15 seconds. That's it here. Hadoop will take 15 seconds. See, there's a lot of difference, right? Where is 20 minutes? Where is 15 seconds? There's a lot of difference. 20 minutes and 15 seconds, lot of difference. So traditional system taking 1 minute. That case, Hadoop will take how much time here? 1 minute. So 1 minute equal to, yes, how many seconds? 1 minute. 1 minute equal to 60 seconds multiplied by 1000 is equal to 60,000 milliseconds, right? 1 minute equal to 60,000 milliseconds. Okay, this is divided by 80. 20 servers multiplied by 480 is equal to how much? 750 milliseconds. It means less than 1 second. Yes, traditional system taking 1 minute here, 1 minute to process same data. Hadoop will take less than 1 second. 1 second is very simple. Just to close eye and open eye. 1 second is over. Within that time, you can process that. Traditional system taking 1 minute, but Hadoop less than 1 second. Maybe yes, 750 milliseconds, 500 milliseconds like that. Within short time, you can process. That is power of Hadoop here. Okay, this is processing power of Hadoop here. So data processing, even big data also can be processed within short time because it's a parallel processing. This type of processing, clustered processing. Hadoop follows clustered processing, parallel processing. Since it's a parallel processing, any amount of data can be processed within short time. Clear? Yes. Next, yesterday I told you one concept. Yes, 100 GB data loading into cluster. So first node itself is having 500 GB free space, right? Yesterday topic. First node itself is having 500 GB free space. What is data here? 100 GB. That means first node is capable of storing 100 GB data, but it won't store in first node. Reason all the 100 GB data stored in single node. What happens? That becomes like a traditional system. No difference between traditional system and the rich. Yes, all these 100 GB data loading in the single system. Okay, there is no difference between Hadoop and traditional system. Yes, Hadoop has its own strategy. Okay, Hadoop strategy is different here. Hadoop always it will try to distribute on multiple nodes. That's the reason here. Next, one more thing here. While distribution also equally distribution here. Suppose here data processing here 40 blocks, here 40 blocks, here 40 blocks like this. Suppose in this node, suppose 200 blocks available here. Suppose here 200 blocks free space available. So 200 blocks stored in this node here. In this node 40 blocks, here 40 blocks. Suppose here 200 blocks of data stored. Next in this 40 blocks, in this 40 blocks, what happens here? All are running parallel, right? Yes, suppose 20 nodes. 20 nodes. Yes, 20 nodes, all are 40, but one node is 200 blocks. What happens here? 90 nodes will complete data process, but the 20th node, 200 blocks, right? That means a block job blocked with this node, right? Job blocks with that node means bottleneck. So because of bottleneck, they blocked, right? Yes, unable to finish that. Yes, waiting for that. Because of one node, entire job waiting, right? Yes, that's the reason. Equal amount of data distributing. Is it clear here? Equal amount of data distributing means all servers has to process data equally here. Parallelly, at the same time they have to finish. Okay. Yes, load particular server. No, that is not Hadoop strategy here. Hadoop follows distribution strategy. Equal amount of data here. Okay. Suppose if not equal amount of data, what happens here? That cluster becomes imbalanced cluster. Balanced cluster, imbalanced cluster. What happens here in Hadoop? Hadoop admin every week or daily you will run the balancer. Once run the balancer, the data will be distributing equally on all the data nodes. Suppose initially here at the time of loading, due to space availability here, maybe storing different servers. Once Hadoop admin run the balancer, that equally distributing automatically here. Equally distributing. So initially at the time of loading here depends on space available, depends on nodes available here, maybe storing. But once you run the balancer here, automatically balancing the data here, means equally distributing under multiple nodes. That's okay. How to run the balancer we'll discuss. Yes, we have the command and the balancer here. I'll explain. That is my experience. Okay, running balancer and checking nodes and all this. Okay, I'll explain very clearly. Practically we'll discuss that. Okay, fine. So these are about storage and processing like this. So you can always, while storing data, while distributing data is equally distribution. Distribution of data is a equal distribution onto multiple nodes. Next, data processing is a parallel. It's a parallel processing that gives a more performance. So distribute data storage and distribute data processing. The distribute data processing will give the more performance. Yes. Okay. Yes, simple. See, one person working for 1,000 people. It's not easy. Lot of load on that one person, right? Suppose 80% are working for 1,000 people, it becomes easy. That load distributed by the 80%, right? Instead of one person here, 80% are working for 1,000 people. It's easy. Suppose one person working for 1,000, it's not easy, right? Load distribution, nothing but simply here. That gives them more performance. So this is about data processing. Okay, right? Yes. Next, data processing. Next is high-end hardware. Let us come to this high-end hardware. See, with traditional systems, high-end hardware required. High-end hardware with Hadoop, high-end hardware not necessary. With Hadoop, high-end hardware not necessary here. What's the reason? Let us see here. See, high-end hardware, traditional systems, high-end hardware required. High-end hardware. So disk, for example, disk. In disk, there are two types of disk here. First one is read disk. This is the read disk. Read disk. Second one here, commodity disk. Yes, commodity disk. Commodity means cheaper hardware. It's a cheaper hardware. Cheaper hardware. It's a cheaper hardware. What's the difference between RAID disk and commit disk here? RAID disk. Suppose suddenly disk failed, no issue. We can get the data. We can recover the data here. RAID disk data can be recovered, but commit disk data cannot be recovered. So disk failed, we cannot recover data. Okay. For example, recently in my system happened here. Just to, yes, 2 months back, my system suddenly crashed. Everything lost. Yeah, complete disk crashed. I was unable to recover that. Yes, even sent some hardware center here, unable to recover the data here. But the thing is here, luckily all the data is already in my drives. Yes, whatever I'm working here every day, whatever data I'm sharing to student, yes, whatever my office work, everything is I'm uploading to drives. I have different drives for different things here, different data. Yes, Google Drives available. Yes, I think around 10 to 15 drives available for me. So 10 to 15 drives, like videos, like class videos, your session videos, next office meeting videos, next office data, next my personal data. For all the things here, 15 drives available. Okay, since 10 years going on data generating, I'm storing drives. Okay, luckily in the drive data is available, so that I recovered. I purchased laptop newly here recently, just 1.5 months back. I purchased this laptop here. Very high-end system with 16, because Hadoop and big data processing here, we need high-end system. So previous that system was 8 GB RAM, now it is 16 GB RAM, high-speed processor. Okay, yes, fine. Hardware with commodity disk, we can't recover data, but RAID disk can be recovered. But RAID disk is a clear here. Yes, 10 times costlier. 10 times costlier. This is 10 times costlier than yes, commodity hardware. 10 times costlier than commodity hardware here. Commodity disk costlier than commodity disk here. 10 times costlier. Okay. RAID disk. Suppose if you want to build this server with RAID disk here, it's a costly. High-end means expensive. With traditional systems, high-end hardware required. With traditional systems, high-end hardware required. When come to Hadoop here, high-end hardware not necessary. We can go with the commodity disk here. We can go with commodity. Reason, see commodity disk. Here using commodity disk. Commodity disk means cheaper disk. The cheaper hardware. Right? Suppose this node is failed. Disk failed. What happens? Maybe you may be asking question. Yes, in Hadoop using commodity disk here. Commodity disk. Some disk failed. What loss of data? No doubt. Loss of data we can't recover. But in Hadoop, there's a concept of replication. Yes, concept of replication factor. Yes, here there is a strategy here. Replication factor. This is a concept of replication factor. This is a concept of replication factor here. This is a concept of replication factor. Yes, defaults replication factor. Defaults replication factor. Default replication factor. Default replication factor is 3. Default is 3. That you can change it. Default replication factor. Default replication factor equal to 3. Default is 3 here. Okay, default once Hadoop install by default is 3. Okay, next minimum replication factor. Minimum replication factor is equal to 1, means 1 copy. Replica means copy. Replica means copy here. So minimum replication factor is 1. Okay, default is 3. Next max. Max replication factor is 512. That means up to 512 copies you can maintain this is, but not like 3 enough. 3 recommended. Okay, 3 reason why 3 recommended. I'll tell you. Just wait. Yes, in next couple of minutes I'll explain that why 3 recommended here. So default replication factor is 3. Okay, minimum is 1, maximum 512. So 3 means for every data it will generate 3 copies. It will generate 3 copies. Suppose 1 GB data loaded, it becomes 3 GB data. 2 GB loaded here, that becomes 6 GB. 100 GB means 300 GB. That's every data it has 3 copies. Suppose let us say first copy here, first copy. So first copy notice is yes. Suppose here first copy, yes. Suppose second copy here, yes. Maybe third copy here, like 3 copies. Suppose this notice for disk is failed, no issue. There are 2 more copies, right? That means backup. Backup copies available. Backup copies available here. Yes, in Hadoop backup copies available. Okay, so 1 copy failed, 2 more copies available. And no problem with that. Suppose second copy failed, third copy also available here. Yes, even failure copy it will recover automatically here. Failure copy will recover automatically. The topic we'll discuss in recovery process. Okay, so here Hadoop has the concept of replication factor here. Any copy failed, we have the 2 more copies. So Hadoop is maintaining backup copies. Even disk failed, no issue. We can use 2 more copies. That's all. So community disk here, cheaper hardware can be used. Yes, not required high-end hardware here. RAID disk is not necessary. RAID disk. This is RAID disk here. RAID disk. RAID disk images. See, this is RAID disk. It's like this. RAID disk. Here like this. RAID disk like this. RAID disk. It's RAID disk. So RAID disk, right? Is a RAID disk like this. It's a costlier. This type of disk is very costly here. This is okay. See, our disk is different. RAID disk is different here, right? Our disk is coming cheaper disk in our systems here. Okay. So here the production server they will use RAID disk here. Real-time production server, maybe banking data, maybe stock exchange data, maybe yes Amazon online shopping data, whatever it is here. Some telecom data, yes, other information. For all this, they will maintain RAID disk. Traditional system RAID disk required, but Hadoop not required because backup copy is maintaining automatically. Right? Okay. So about yes, community hardware. Cheaper hardware can be used with Hadoop here. So Hadoop is not expensive here. Okay, cheaper hardware can be used here. Okay, traditional systems 10 times cost. Disk is 10 times costlier. Okay, so it's not expensive here. Cheaper hardware can use. Cheaper hardware can be used. Okay, fine. So next, very large files. Very large files. See, Linux or Windows operating system. Very large files cannot handle. Maximum size of the file that can be created in Linux base. Maximum size of the file. Very large files. Very large files here. Very large files. Hadoop can handle very large file also. But Linux, Windows cannot handle very large files. Very large files. Yes, in Linux, maximum size of the file. Size of the file in Linux. Linux is equal to here around 65 GB, not more than that. 65 GB. Maximum size of the file in Linux space is equal to 65 GB, not more than this. Yes, I will tell you proof also. 1 second. Yes, that calculations here. My practical experience. Yes, even I worked on embedded C. Okay, that's the reason I have that knowledge in that area also. Okay, my first 2 projects are embedded, later converted into Java. Yes, 2013 hours big data Hadoop applications. Okay, still I'm working on embedded area also. Currently, some 8 months back, we have delivered one embedded projects. Okay, unique shell scripting and C language networking Based on that, we have done one project that was delivered. Okay, 1 second. Just Linux. Yeah, Linux. See here, I'm taking Linux patches and Hadoop patches. Okay. Yes, sir. Evening 8 o'clock, Linux patch is going on. This morning hour, just Hadoop I'm taking it. 1 second. Node. I know this is the concept of I nodes. Array of 13 pointers. Pointer 1 to refer to first 10 data blocks. Pointer 11. Yes. 256 pointers. Pointer 11 to array of 13 pointers. Size of each data block equal to 4 KB. Linux. Previously we discussed size of each block equal to, yesterday we discussed it. Linux size of each data block equal to 4 KB. Then pointer 1 to 10. Yeah, this calculation may not be understanding for you because this concept is not known for you, right? Yeah. So 10 into this is 40 KB. 11th point is 1 MB. 12th pointer 256 MB. 13th pointer is 64 GB. Total is 64 GB plus see 40 KB. This is 40 KB plus 1 MB plus 40 KB plus 1 MB plus 256 MB plus 64 GB is equal to around 64.2.5 GB. Means around 65 GB of data. Yes, Linux maximum size of the file that can be created is equal to 65 GB data. 65 GB data, not more than that. But in Hadoop, there is a chance of sometimes generating very big, very large files, more than 65 GB data, maybe 100 GB data file. Suppose in 100 GB data file generating on the Linux file system, it fails simply. Linux file system fails, it can't take 100 GB data here. Max is 60 GB taking, not more than that here. More than 60 GB, it simply fails. Why is that Linux OS itself fails? It can't take. Okay, reason on one computer, it can take only 65 GB data, not more than that, right? When come to Hadoop here, if Hadoop what happens here, suppose 100 GB data is there. That 100 GB data distributing into multiple nodes, right? Multiple nodes. That means on each node, how much data? Only 5 GB data. Yes, 5 GB data, no problem. Up to 65 GB data. See, these are all Linux systems, all are Linux computers, all are Linux computers, all are Linux, everything is Linux. On each Linux, in this system here, in this Linux, max is 65 GB file. Like that, many number of files, no problem. Yes, maximum size of the file 65 GB, 65 GB, here 65 GB, that's the maximum. Okay, suppose in traditional systems, data generating 100 GB, that all the 100 GB data has to store in a single system, right? Yes, complete whole data, 100 GB data has to store in a single system. Yes, 100 GB file cannot store on single system, not possible. Max is only 64 GB. But when come to Hadoop here, that 100 GB is splitting into multiple blocks and distributing in multiple nodes. That means on each node 5 GB. Yes, it can take 5 GB. This Linux base will take 5 GB. This Linux Hadoop cluster is running on top of Linux base. Always Hadoop cluster runs on top of Linux base. Okay, so behind the Hadoop file system, this is Linux file system. Yeah, this Linux file system, why not handling 5 GB? It can handle 5 GB. So 5 GB, 5 GB, 5 GB. That means file is breaking. After breaking, storing files here. Okay, in Hadoop, what is happening? Even very large file also breaking into multiple parts and storing in multiple nodes in cluster, so that it can take big data file also. So that is very large files. Okay, yeah, that's all. Yes, next one. Next
Sir,
one.
I have a question related to replication factor.
Tell me.
And the replication factor, it means this is a strategy to have a backup on the other node, correct?
Yeah.
This is what I understood. And
three
we
copies
have a
3 copies on 3 different nodes, not on the same node.
yeah, on a different node. See, suppose we have a replication factor of 3. It means we will be having a three backup copy on different node. So suppose we have suppose in this example, whatever you explain, we have a 20 nodes. So first node, for the first node, we will be having the three backup copy on a different
Yeah,
three node.
right. Yes, totally
And
60 nodes.
on the, okay, and
Total
for the second node, we will be having a other three node.
three. Yeah, right,
So
right. You're
how
right.
they,
What
correct?
you're thinking is right. Correct. Correct, right.
Yeah. So suppose, sir, means suppose node number, any node is failed, but I am having a backup copy on there. So if any node is failed, but I can retrieve the data from the another node. This is
Yeah,
the
right.
concept, right?
Yeah, that's a concept. That's it. Okay.
Yeah,
Yeah.
means I correctly understood.
Yeah, right. What you say? See, they were data distributing under 20 nodes. Each node copy replicating to
Yes.
that means 20 multiplied by 3 means 60 nodes. The data becomes 60 nodes. Clear? 60 different nodes. 60 copies are storing at 60 different nodes. Clear? Okay, right? Yes.
Okay. And sir, one more question means how we
Yeah.
are deciding see suppose node one. So how we are deciding where we put the backup copy on which node?
Okay. That is replication strategy. There is a rack awareness thread. Name node contains one rack awareness thread. That rack awareness decides where to store your data. Yes, that is not in our hands. That is not manually. Name node is having one thread called rack awareness threads. That rack awareness thread will find the location, will identify the location of that location providing rack ID, node ID providing rack ID, node ID, block ID. All these things are providing here. As per that, name node will distribute data. Okay. Yeah, it's a separate topic that time we'll discuss. Okay, metadata concept is that time I'll explain very clearly. Okay,
Okay,
this is a
sir.
rack thread. Rack awareness thread will identify the locations where to store your 3 copies. Okay, yes, we have separate topic. I am not skipping. Separate topic is that time we'll discuss. Okay, right time I should discuss right topic. Okay, at this stage may not be understanding that internals. Okay, yeah.
Okay.
Any other? Yes. Next, backup. See, just now we discussed backup copies meaning automatic recovery. With the backup copy, it will recover automatically, right? Disaster management. Because of 3 copies pending, even disaster also no problem. Natural disaster. 1 copy failed, 2 more copies you can use. That's all. So these are big data challenges. Okay. Yeah, that's all about just worry. See, 1 second. Till now we discussed just only worry we discussed. We have discussed internal topic. Just only high level we discussed it. Next, we should discuss internals. Okay. When you can understand internals, once you set up the Hadoop, then you can understand internals. So once we set up the Hadoop, you can understand internals, right? Yes. Tomorrow class, Linux setup. How to set up Linux system? Yes. For Hadoop purpose, first of all, you have to set up the Linux base. On top of Linux base, you have to set up the Hadoop. Okay. Tomorrow we are going for Linux setup. Next, putty, WinSCP, these concepts. Tomorrow, day after tomorrow, Friday, Saturday. Okay, 2 days, Linux, WinSCP, putty, all the setups. After finishing that, Monday we'll move to, yes, Monday we'll move to Hadoop. Okay, 1 minute. Monday onwards, your class starting at 9 o'clock. Okay, yes, my work, my office time, check with your batch students also. Finally match with 9 o'clock, 9 to 10:30 class from Monday onwards. Not now. Friday, tomorrow, Friday, Saturday, same time, 11:45 starting here, Friday, Saturday here. From Monday onwards, 9 o'clock. Please plan for that. 9 to 10:30. Till end of the batch, no changes in time here. 9 to 10:30 batch. Is it okay?
Yes,
Sure,
sir.
sir.
I'm fine with this time.
Yeah. So 9 to
The 1.5
10:30.
hour time, 1.5 an hour,
Yeah, 1.5 hour compulsory. I need 1.5 hour.
and Monday to Saturday.
Yeah, Monday to Saturday. Definitely. Monday to Saturday, no doubt. Okay, right? Suppose if I'm taking leave due to some office work, something, I will inform. Okay, just 1 hour before or 1 day before, I'll inform you. Don't worry. Right? Yeah.
Okay, sir.
Sure, sir. And I'm
Yeah.
curious to know about your background, like where are you currently working and how much experience you have on Hadoop and any other technologies that if you worked so far. So just out
Yeah.
of my curiosity.
Yeah, no issue. I can. Yes, first class itself finished here. Yeah, this is Nageswar Rao. I'm Nageswar Rao. Yes, Nageswar Rao. Yes, my work started in 1997. 1997. Okay, 1997 engineering complete immediately within month. Yes, yes, it's a campus selection actually here. Okay, 1997. Yes, yes, engineering topper, college topper. Yes, JNT Kakinada. Yes, like my MSET rank was 126. MSET rank at that time 126. So BTech computer science taken here. Yes, final year got the job. Yes, September month they have given apartments and joined in 1997 September. I think the same this month joined. First my job with Motorola company. Motorola company. Yes. First my job was Motorola. Yes. Stop the recording. Let us stop our recording. Again, sorry. Okay. So first Motorola company. Yes, in Motorola company, my first project is embedded C project. Embedded C. Embedded C project here. That is voice development. Yes, complete Unix ways we have taken, modified, and developed separate platform for the Motorola devices. So my first project. Next, second project. Yes, sir. SMS gateway. SMS gateway for Maxis Malaysia. Maxis Malaysia company. This is Maxis Malaysia. Yes, this is my payroll company is App Labs. I have changed that company here. App Labs. Changed the App Labs. Okay. Yes, this also embedded C project. SMS gateway. This also embedded C project. Linux we have developed. This is Maxis Malaysia. Okay. So first project embedded C with Motorola. Second one App Labs company. Client is Maxis Malaysia. This matter Motorola their own product. No client for its own product. This App Labs next. After that, next in 97 started career. Okay. Yes. 97, 98, 99, 2000. Up to that, I'm in embedded C. 2000 year, yes, Java very crazy that time. So I moved to Java. 2000 year started Java career. Same App Labs. Same App Labs company. Just I have converted to Java here. Just learned Java and started working on Java here. Okay. Next after that, 2003 changed to another company. Yes, Visual Software. Yes, Visual Software, very world company, very famous that time. Visual Software is very famous. Okay, yes, 2003. Yeah, that time Satyam company is there in Hyderabad, very famous. It's a partner, Visual Soft. Satyam Raman, yes, he went to jail and something was happened due to some dirty politics. Okay, so 2003. Yes, 2003 here, Visual Soft. Visual Soft is a partner of that Satyam Ramalingas. They are brothers, both are brothers. Okay. Next after that, 2007 changed to Diebold company. Diebold. It's a ATM machines manufacturing company. Yes, in Visual Soft, yes, almost 3 projects complete on Java. Yes. Matrimony, the Shadi.com is there, right? That time we have developed.
Hello.
That
So it is
Shadi.com is there.
Naveen.
Yes. Yes. Yes.
Okay, fine.
Almost three projects were finished in 2003. Okay. Half red. 2007 changed to Diebold company. Diebold is a product-based company. They're having their own products. Many products are
Yeah,
there.
I'm okay.
In Diebold, worked
Yes,
on
yes.
next Oracle database.
Yes, ma'am.
Oracle database maintenance here.
Yes,
Yes.
I'm fine.
After yes. Next Linux area. This area worked here. Okay, Java, yes, Oracle database, on Linux. This area I worked.
You didn't get any.
Okay.
Didn't see any reply.
Yes, after that, next. So next one.
Okay,
See.
okay.
One second. Okay, let me meet him. Yes, next. Yes, Java projects. Yes, Oracle database, Linux, this area I worked. Okay, after that, 2012 at the end, what was happened? Diebold company, in this company here. Yes, Diebold ATM machines manufacturing industry here, many clients across the world, many countries, 165 countries, this Diebold company having clients. Okay, so a lot of business. So 2012 at the end, they started facing big data problem. 2012 year started facing big data problem. Okay, yes, to work on big data, yes, they are looking for the who is having knowledge in Java, Oracle database, Linux, this area. Okay, they are looking for that in the entire company. Yes, more than 10,000 employees are there, software employees here. Yes, they are searching for this case. So they identified me. And apart from me, yes, 4 more guys. Totally 5 to 6 members they have identified and formed some team. After forming team here, they asked me to come to US immediately. So business visa. Yes, 2012, September, October, November, December. No, September, October, November, 3 months. 3 months, 84 days, we went to US. On-site work. Started working on Hadoop. Okay, we have taken KT from the Apache Software Foundation. Yes, somebody came to that office here, Chicago. The Diebold main data center at Chicago. We have taken KT. So 80 days taken KT. After that, we have traveled to Hyderabad. He has started working here, right? After that, they have started processing L1 visa. Yes, that entire team. Yes, we have migrated. Yes, they have processed L1 visa for 2 years. 2013, 2014, I was there in US at Chicago. Near Chicago, there is a Cleveland is there. Cleveland Airport. Nearby that, yes, nearby North Canton is there. North Canton. Yes, North Canton. Yes, you can check Diebold North Canton office. Yes, now it's changed here. Diebold next up. Yes, North Canton. This North Canton warehouse state. Yeah, this is our main office. This is office. Yeah, this is the office. Diebold. Not DN. That changed logo changed recently. Okay. Yes, with a bigger tie-up with another company. They have taken over another company, Nixdorf company here. They are tie-up with that company now. So it's a very big office. Yes, a very big sales. Yes, more than 1,000 acres sales. In that sales, some big lake also there. Okay, weekends we used to boating. We used to do the boating, something like that. Okay. Yes, 2 years I worked here. Yes, it's like a village and peaceful environment and happy working there. Okay, 2 years worked there and returned back to Hyderabad and continued. Yes, in that here, big data here. First, if that company has the data with the different data like SCM, supply chain management module. They are using Oracle ERP yes, to manage supply chain management. Supply chain management in the various departments like production departments, various departments, next manufacturing departments, next quality control departments, next shipping departments here, next assembling departments, yes, marketing department, all the different departments generate different data. So for that, they have purchased Oracle ERP. They are using Oracle ERP. Okay, Oracle ERP, that ERP generating a lot of data. Yet to store that data, process data, they are planned to use Hadoop. So my first Hadoop project is SCM project. Is my first project in Hadoop. My first project. This is in 2013. Yes, sir. November month started. 1 year we did R&D on this, like cluster setups and all this. Here, yes, 1 year R&D. That time we learned lots. After R&D here, 1 year R&D here, we came to some idea here. Then we started working on SCM projects. SCM projects. Okay, this SCM project almost was taken for 2 years because first time working on Hadoop here. Okay, it was taken for 2 years. So 2013 November started here, 14-15 that SCM project completed. So this is on 1.x version. 1.x version. This is. Okay, after finishing SCM, next human resources management, because Gboard is having many number of employees. Okay, to manage all the employees here, HR module. Okay, HRMS is nothing but HRMS. These are all the modules in the Oracle ERP. HRMS data. These second projects. Second project. Next, our second projects. Okay. Yeah, before this 2012 here, yes, on Java, almost seven projects were completed. Java. Embedded C 2 projects, Java 7 projects here. After it, big data projects. So HRMS projects. So this is 20. Yes, 2015 middle started here. Yes, 2016. Yes, middle finished. Yes, 1 year we have finished with 1 year because already existing jobs are there. Okay, already existing is there, everything is there here. So within 1 year we have finished that is. Okay, after HRMS data here. So next one is yes, Dboard having lot of assets module. This is second project. The second project, this is third project. Third project, assets. Yes, analyzing their assets. Okay, various location assets here. So what is the assets value? That kind of things. Second, third project. This is after finishing on here. Next one is so first SCM data, next HRMS data, next asset Dboard assets. Okay, after this here. Next Dboard accounting system, financial accounting system, accounting data here. This is most important, accounting data, because expenditure and all this income and outcome. Yes, that is Oracle pay module, Oracle receive OR module, OP module like this. So there are some modules. That data, yes, we have started working here. So this is fourth projects. So this is yes, this is 6 months. Within 6 months is a very small project. Assets is small projects. Okay, just 2016 mid started here. Yes, 2017. Yes, Feb completed the project. Just 6 months we have finished here. Okay, next fourth one. Yeah, this also just 1 year project. Accounting project, only 1 year project. Yeah, 2017. Yes, 2017 Feb 2. Yes, around Feb that time here. Why February started here? Generally here in US, December month, January month, maximum holidays. Okay, that time starting project in Feb. Generally US market always starting Feb. Yes, March month more recruitments, right? Okay, because of that Black Friday holidays and year-end holidays here, year beginning holidays. Many yes, that time 1 month minimum every software person US they will take 1 year. Not only software. Everyone, every person will take 1 month, they will enjoy for 1 month. Okay, that time we don't have any projects. We will not work on projects here. Okay, so 2017 Feb started here. So this is 27 ND completed. 2017 ND completed this project here. After that, next project, see, these two are 1.x version. Yes, next this project is 2.x version. This is second version, 2.7.2. Second is 2.x version. Next, this also second version here. This project also second version. 2.x version. Second. So next project, same SCM data. Yes, we have converted to Spark application. This SCM, this is fifth project. Fifth project SCM. So this is started 2018. 2018 Feb month started. Same that Feb month. Okay, 2018 Feb month started here. Yes, migrated that SCM data because huge amount of data. So Spark, we thought as that Spark with a better performance. So we have converted that migrated this SCM project. The first project was converted into yes Spark application. So this on Spark. Spark. Okay, so 2018 started working on Spark. Spark only 2 years of experience because Spark just only 2017 came to the market. Okay, in 2017 only came to India. So before that we don't have that. Okay, 2018 started on Spark. Okay, that one project completed. Okay, now currently here another project. We are doing another project here. We are planning for another project. 2018 Spark 2018 to 19 end 2019 end 2019 end. Yes, that project complete here. Next again February months planned for this accounting system for the this data here, this accounting plan, but not yet started. Still we are working because these are COVID problems here, all the issues here. That project working stop. Okay, maybe starting after 2 months. Okay, now we are in somewhat relax. Okay, work from home, somewhat in relax. Okay, yes. Here this is next project, maybe this is. Yes, by the time here, what we are doing here, 2019. Yes, at the beginning of this 2020. Yes, from embedded C project support project we got it. Embedded C support projects. It's not support for migration projects. Yes. Yes, previously I worked on that embedded C area. So because of that project, yes, I accepted that project. Then started working on this. The 2020 beginning started working on this. Yes, since the 2020 beginning till last month, I supported that project. That complete agreement completed. Just only 8 months project completed. Over. Now that is over. Yes, even relief from the client also. Just last 1 month, I'm in somewhat relaxed. Now I'm in relief here. So next project you have to plan. So this project is pending only here. Yes, maybe may not be working, can't check it. Next project, if new project comes, you should go for new projects. Okay, that is my career. Okay.
Oh my God, almost 2 decades of your career in IT industry. That's a way long journey.
See, one second, I'll tell you one thing.
All your milestones, sir.
One second, I'll tell you one thing here. I am more than the software industry. I can tell any doubts from Java, any kind of issues I can resolve. From Java side, Hadoop side, Linux area, this area, any kind of issues I can solve it. Because many of my customers, maybe some relationship, because of relationship, many of guys are asking to solve some issues. Sometimes I used to get small assignments like this as a consultant. Okay, sometimes getting that also. So I'll be working for that also. Okay, apart from my present company work here, maybe sometimes parallelly working in other companies because of helping us. Even of course they will pay something here, no doubt. Okay, yes, lot of experience. Just see 1 second. What are the topics I'm explaining here? Sometimes you will not find in Google also. Yes, in Java, what are topic explaining? Suppose sometimes Java explaining, sometimes see this Linux explaining here, sometimes Hadoop explaining here, what are topic explaining. Even you can't see in Google also. Okay, some of my experience is almost more than Google. Okay, yes, some topics you not find in Google. That I have that much of experience. Not only experience, dedication important here. 20 years completely dedication. Okay, minimum every day I worked for 12 to 13 hours. See, having experience is not 20 years of experience period. That period is not important here. Maybe 2 decades or 3 decades. That period is not important here. Dedication important here. This on how much R&D we did on this here. How much technology is not here. That is very important. Okay, I'm good at database. I'm good at Linux base. I'm good at Java, including Spring Framework and Spring Boot also. Okay, yes, next. Apart from this, Oracle ERP also good at, but I not worked with Oracle ERP because of that Hadoop projects. We worked sometimes on Oracle ERP also, but not expert in that area. Next, Hadoop area, big data area, on this Spark area. Next step on Python. In projects, some of the projects we use Python also. This area I'm an expert. Okay, any kind of issues I can solve it. Yes, even coding and everything topics, everything in fingertips. Okay, actually teaching while taking classes, that is my passion actually here. Not only working here, teaching is my passion. Yes, I want to share my knowledge to many guys. That's the reason parallelly taking class also. Yeah, this is happening since my beginning. 1997, at the age of 21 years, C language I have taken classes. Yes, in Ameripet, some institution, morning one batch, evening one batch. I have taken classes on C language. On C language, 1997. Yes, my career beginning just at the age of 21 years, 97, 21 years. At the 21 years, yes, without any fear, started teaching because that is my interest actually here. Okay, that interest converted to passion now here. Okay, so finally, software has become passion for me. Yes, every day R&D. Yes, every day I learn new technologies. Every day new things. Okay, see now I'm doing R&D on Ignite. Ignite. This is next generation. Hadoop, half Red, Spark, after Spark, next is Ignite. Yes, traditional systems failing, that case using Hadoop. Yes, Hadoop, even data limit crossing Hadoop also. That size, that case Spark. Spark high speed engine, even sometimes data maybe chance of crossing Spark limit also here. That case Ignite. Next generation engine is Ignite. Very, very high passing engine here. Okay, see here Hadoop 100 times better than traditional systems. Next, Spark is 100 times better than Hadoop here. Ignite is 100 times better than, yes, the Spark machines. Spark engines, but Spark engines, Ignite engine, that case high-end systems required. Yes, Spark engine, okay, fine, but Ignite engine, very heavily high-end systems are required. Yes, now, top 10,000 companies reach to Hadoop range. Top 10,000 companies in the world, they are reached to Hadoop range. Top 10,000 companies. Top 1,000 companies reach to Spark range. So Hadoop range, top 10,000 companies. Next, Spark range, almost 1,000 companies reach to Spark range. Next, top 10 companies reach to Ignite range. So this Hadoop range, this is Hadoop range. Yeah, this is Spark area. Yes, top 1,000 companies, top 10 companies like Facebook. Okay, next Google. These were, yes, YouTube. They were reached to, yes, even Ignite range also. Reached, but they are not using. Still, they are using Spark only. Yes, Ignite, this maybe will come in 2025. In 2025, I have to move to Ignite. Okay, what was happened here? See, up to 2010 traditional systems to maintain data here and all these traditional systems. Yes, up to 2010 here. Yes, 2010 to yes 20 Hadoop. This years Hadoop. Okay, sorry, 20 up to 10 to 10. See, as IT started in 1990. 1990 to 2010. That means how many here? 20 years. 20 years traditional systems used. Next, that 20 years of data generating in only 10 years. So 2010 to 2020. Yes, not 2020, even 2015 up to this Hadoop. Okay, Hadoop. Yes, 2015 started. 2015 started Spark. Yes, 2015 releases Spark in the market here, but using from the 2017. Okay, 2015. Yes, now 2020, right? We are in 2020. Now Spark is going on. Okay, suppose reaching to 2025, then it's a Ignite. 2015. 2025, we have to start with Ignite here. Up to 2025, Spark will be there. Okay, so if you have first 20 years, traditional systems, next 10 years, yes, next 5 years, or next 2010 to 2020, this area, Hadoop. Next 2015 is Spark started. 2025 Spark. So traditional systems 20 years, Hadoop 15 years, yes, Spark 5 years. Next Ignite. What is happening in industry here? That is my practical experience, my live experience. Okay.
So, sir, how we can move our career to here? Because we are on the beginning of starting the learning the Hadoop.
Yeah, I'll tell you. Yes, how to move on to Hadoop here, I'll tell you. For Hadoop, particularly SQL basics required. Next, Linux required. Okay. Yes, little bit Java. Java much not necessary here. Just one little bit is enough. Okay. Yes, of course, I'll explain the Java concepts in Hadoop. No worry. So SQL Linux required. Yes, after finishing this course, you can put up minimum 4 to 5 years of experience. That much I'll explain here. Don't worry. Yes, how to put up experience, I'll tell you. Okay, how to put up experience, how to prepare resume, how to face interview here. All the things I'll explain. No worry. Right? Yes, any doubts? If no doubts, let us find a session. Tomorrow, we'll be going for Linux setup. First, you have to set up Linux. On top of Linux, first you have to set up Hadoop. So tomorrow, Friday, Saturday, yes, about Linux topics. Monday, we'll be starting Hadoop setup. Right?
At 9 o'clock.
Yeah, Monday 9 o'clock, sure. Monday at 9 o'clock. Okay, right?
Okay.
Yeah.
Sure,
Okay, sir.
Yeah.
Thank you.
Thank you,
Yes.
sir. Have a
Sir,
great day.
one small thing. So are you
Tell
going
me.
for, yeah, are you going to start the Spark also? So before
Yeah.
learning Ignite, we should know the Hadoop and Spark, right?
Yeah. 28th on 28th starting Spark and Scala batch.
28th of September.
September, yeah. September 20th of September starting Spark and Scala batch.
So, sir,
Okay.
can we parallel start both classes or
Yeah.
first we finish the Hadoop, then only we
Yeah.
should learn the
Thing is
Spark?
one. At the beginning, Scala for 4 weeks. 4 weeks, this is like a language, this is. Learning like a language. A Scala will be taken 4 weeks. By that time, Hadoop almost 80% will be finishing. Okay. From 28th onwards, Scala starting. Scala will be taking for 4 weeks. So that 4 weeks, like this 2 weeks, total 6 weeks. 6 weeks means almost Hadoop will be finishing 80%. Okay. You can understand, no problem. No issue. Okay. I'll coordinate. No worry. Right?
Okay, sir.
Yes, scale up that not yet announced. I'll inform you. Wait.
Hmm.
Next week.
Hmm.
Yes. Next, anything else?
Sir,
Nothing?
can you add me in the WhatsApp group? You didn't add me.
Yeah, sure, definitely. I'll share in the group.
Yeah.
Yes, I'll everything I'll update in the group. No worry. So if I'm start like just 1 week before, I'll inform you definitely. So mostly I'll be announcing this one is on Wednesday. This is 22nd or 23rd. I'll announce it. 28th batch. I'll announce on 23rd or 24th. Right? Okay. Yeah.
Hmm. Oh,
Yep.
okay.
Right?
Yeah,
Yes.
sir. Okay. Thank you.
Thank you. See you
Hello?
tomorrow. Yeah, tell me.
Sure, sir.
ये तो collaborable करती रहना है
Yeah.
Okay, sir. Bye bye.
See you tomorrow.
direct collaborate